Okay, good morning everyone. I'm Federico and I'm gonna try to explain you how to solve the good exercises that Mr. Coulomb gives us. So we're gonna start solving the exercise number 7 from the inclined planes and forces. This problem says a box starts from rest and accelerates down the ramp. What will be its velocity if the ramp is 5 meters long? So how we can see from the problem, the mass of the box is 50 kilograms and the angle is 48 degrees and mu k, so the coefficient of friction, is 0.23. So to solve our problem, we're gonna draw the schema of the problem and our FBD. The most important thing to show is that we are gonna draw our gravitational force in the two vectors that compound this force, that are the force perpendicular and the force parallel. Then we're going to identify what we need to solve this problem. We need to know the Newton's second law, force equal ma, and then in this problem we're going to find the force parallel, the net force parallel to the plane, then the acceleration, and the final velocity at the end of the plane. So first thing, we have to identify that the net force will be equal to F parallel to F of the friction. So F parallel is the component of the gravitational force of the weight of the box acting down in the inclined plane, while the frictional force is acting in the opposite direction. So that's why we're gonna find the difference between those two. And using the formulas, we are gonna say that using trigonometry, we will say that F parallel will be mg sine of theta, and F of friction is gonna be mg cosine of theta, that is equal to F perpendicular times mu k. That's because F of friction, the force of friction, depends on the weight perpendicular to our surface. Okay. In the next step, we are gonna put those equations in the same line, and we're gonna do. And we're gonna say that the acceleration is equal to our net force over mass. So we're gonna write this final equation. And how we learned today, it doesn't matter how big is your mass, because your mass will increase both the frictional force and your force going down because of your weight. So they will cancel out, and we're gonna have this final equation. A, the acceleration, is equal to g times the sine of the angle minus cosine of the angle times mu k. Okay, now we are gonna plug in our numbers. We don't need to calculate new numbers. We know all of them because g is equal 9.81, and with our calculator we can figure out which is the sine of 48 and the cosine of 48. So we're gonna find that the final acceleration will be 5.778 meters per second squared. Okay, so in the next step, now that we know the final acceleration, we're gonna find how much time does it take if the ramp is 5 meters long. So using the formulas that we know from the first unit, that was kinematics, we're gonna say that x is equal 1/2 at squared, and we're gonna change our formula to find the t. Time will be equal to the square roots of 2x over a. Plugging our numbers in the equation, we will get the time is equal 1.31 second, 1.316 seconds. Sorry. So now that we know this, we know we're looking for the final velocity, we know our acceleration, and we know for how much time the box is accelerating. So the final velocity will always be equal to a times t plus v naught. Since the box starts in still without velocity, our final velocity will just be a times t. That how we can see there, we're gonna find that the final velocity is 7.604 meters per second. Okay, so this is how we solved this problem on the inclined planes and forces worksheet. We can always use these formulas that we show during the video to solve any kind of problem with inclined planes, and the best way to improve our skills for this topic and be ready for the test is trying to do more exercises and more homework, and just to understand and be able to repeat this work, understanding well what we are calculating and why. I hope this video would be easy to understand and useful to you. And okay, thank you, good luck.